In this industry, new technologies and innovative practices like precision farming are poised to make dramatic improvements to productivity and potentially feed a lot of people. And so what we're going to be talking about is innovation in that sector, how we can do that, what lessons there are for your sector and for other sectors. So let me start by asking you, if you wouldn't mind giving the audience a little bit of background about the Climate Corporation, which is a company that Monsanto bought, why that was and how that came about.
Sure. So the Climate Corporation is a company that started around 6 years ago, and it's a data science company in San Francisco. And they started actually by modeling weather from an insurance perspective and doing parametric weather modeling. And began to realize that they were looking at industries that were affected by weather and quickly came to the conclusion the largest industry that's affected by weather is agriculture. So that was the origin of the company. It was founded by two folks from Google, and like I said, it was formed about 6 years ago. Monsanto has been in the precision ag space, and I actually prefer to call it now the digital ag space. And we had started doing work in that area around 2010, 2011, which is fairly typical as we think about innovation for Monsanto, where we bring small teams together, give folks some freedom to go ahead and think broadly about how we can go ahead and bring new products to market and what are evolving and new trends that we see on the horizon. So we had a small group of scientists working in this space. We began to develop some products mostly focused around our seed footprint. But quickly began to realize that farming was digitizing, that growers had an enormous amount of information, digital information, that they didn't really know what to do with. So we came across the Climate Corporation and saw their capabilities in data science and software engineering and their modeling capabilities, particularly around climatology and weather modeling, and began to have conversations with them, and we began to see how bringing the two companies together could really spark I think a revolution in agriculture in this digital ag space. And so, you know, as we do an awful lot in Monsanto, it's a question of, do you want to build it yourself, or do you want to go ahead and how do you accelerate innovation? In this case, it was really clear to us that there was an asset that had all the pieces that we needed, and so we went ahead and did the acquisition.
So could you unpack what you mean by a green data revolution, which is a word that I've heard you use, and kind of what that means in the context of what your two companies now one are doing?
Yeah. So if you think about agriculture, historically, I think there's been two clear revolutions in agriculture. One was called the Green Revolution. It started in 1940 with Norman Borlaug and breeding, and actually progressed through the 60s, where those breeding technologies really went ahead and allowed a whole bunch of new plant varieties to be developed and step change in our ability to produce food. The second revolution, I would say, was the onset of biotechnology and advanced breeding technologies that were based on what we call marker-assisted breeding or DNA technologies. And Monsanto initiated that with the launch of our first product in 1996 and has progressed since then. The green data revolution is how we're thinking about the future and was a key reason why, again, we made the acquisition of the Climate Corporation. And it gets back to the fact that the farm is digitizing and that data can be used to develop models, agronomic models, that provide insights to growers that allow them to make proactive, real-time, actionable decisions on their farm to improve productivity. So if you think about farming, historically, people who are in farming, farmers are looking through the rearview mirror. They realize there's a problem only after they've recognized it existing in their field. They plant. When the crop comes up and it emerges, they realize they had a problem with their planter because there was not uniform distribution of seed. They go into the field, they see a disease is already present. Well, the disease is already present in the field, it's already beginning to rob yield. So that's kind of the rearview mirror data and this green data revolution is going to allow through modeling for these proactive decisions to be made. And so we really feel that this is the next wave that's going on in agriculture. And you can see it happening if you just look at this concept of the digitization of the farm. If you go 10 years ago, a grower will on an acre of land, a grower can generate around 6 gigabytes of data if they image their field, they have satellite imaging. It cost about $300,000 for that grower to store that 7 gigabytes 10 years ago. Today, it'll cost 28 cents, and it's quickly going to zero. You know, these things, there's more of these on Earth than people, right? And these are just advanced sensors. This is all happening around us. It's driving innovation in agriculture. So that's how we think about this digitization, the green revolution, the green data revolution in ag. That data ultimately, and multiple different layers of it, the folks that can go ahead and find ways to gather that data, establish platforms that growers will allow for transfer of that data, upgrade the value of it through modeling, and provide insights, actionable insights back to the grower that creates value. That's what's going to happen in agriculture. And it's going to happen a lot faster than it took for the development of ag biotech, which started in 1980 and got launched in the mid-90s, or the work that Norman Borlaug did, which started in 1940, and 20, 25 years later. This is happening now. It's happening at an accelerated pace.
So what kind of timescale are we talking about? Are you talking about?
So we launched our first products in the marketplace this year just a few weeks ago. When we made the purchase of the Climate Corporation, I would say that there were 2 or 3 other companies in that space 14 months ago. I could list you 20 companies now in the space of this digital ag space, and there's a lot of capital out there chasing this.
Would it be unfair to say that you're going to be taking the farmer out of farming in the same way that the drivers are going to be coming out of cars?
No, I don't think so. I think this will change farming. I mean, you can go talk to farmers who farm large acreages in the U.S. It's like 10, 15,000 acres. And the way they farm will change. They are absolutely, and the technology is available to go ahead and have driverless tractors and allow, but the grower is still going to want to have a mechanism where all that data comes to them in real time and they're monitoring the operations on their farm. They might not just be sitting in the tractor doing it. And if you've ever had a chance to go ahead and ride with a grower who's harvesting their field or planting seed, it can be a pretty boring job.
You make farming sound very kind of, it's starting to be very far removed from its roots. Monsanto is a big company, and I'm interested in why it had to sort of buy in this sort of innovation. It seems to me that it's the sort of thing that perhaps Monsanto ought to have been doing for itself. Maybe you could talk a bit about that.
Sure. We started working in this space, like I said, in 2010, 2011, and we made the purchase of a Climate Corporation in 2014. So we were dabbling in this space, and again, the innovation piece of that was how we had a small group of folks really looking into precision ag and how we could innovate at Monsanto. Ultimately, it comes down to a make or buy decision. What's the quickest way to go ahead and get scale and the assets that you need to make a difference in the marketplace? And there's 2 choices. You can build it or you can buy it. And so if we did not identify climate, if climate didn't exist, if we didn't feel that it had the right fit, the right assets, the right connectivity and overlap with Monsanto, we certainly would have gone ahead and built this platform ourselves. It would have taken longer, probably 3 to 4 years longer. But there's speed is important, particularly in this rapidly moving space. And the reality is, we spent $1 billion for a company that had $20 million in revenue. So that's the economics of speed as we see it in the agricultural space when it comes to this digital ag and the green revolution.
And yet, at the same time, you're saying that you've got a lot of competitors now kind of moving in. You've got growing numbers of people moving in. So you're, even though you have this kind of more innovative company within Monsanto, presumably you're at the same time having to think, how do we continue to move fast while we're being absorbed by the sort of giant tentacular forces of the dinosaur that is Monsanto, but we still also have to keep up with these young upstarts? I mean, how do you square all those different dynamics?
Well, one thing is that we're operating Climate as an independent piece of Monsanto. I joined the company, in October. The founder, the CEO, is still present, and a lot of the early inventors are all there. And so part of it is the reality of that, Climate is a smaller, innovative company that's moving very rapidly in a rapid space, and recognizing that if you have a big company like Monsanto coming in, not that you would want to slow them down, it's just hard to not have your processes and your, just all the things that go with a $16 billion company, not, that inertia over there slowing things down. So we're operating the company separately, although we have very, very, very close interactions.
And do you see that as a key part of kind of maintaining that innovative force, is to have that as a separate company? Is that, I mean, you often see that, don't you? In lots of other
I think it's been very, very helpful in my experience in working in my time at Climate. And again, it's more along the lines of, hey, what do you want to push away that slows things down? And there's some things that actually speed things up. So, in Climate, we're doing a lot of things on spreadsheets, getting the company in the back office on SAP. That makes a lot of sense. It's not slowing down innovation. It's actually allowing the company to operate more effectively. But, excuse me, you definitely need to go ahead and create an environment that allows for innovation and rapid innovation. And they had that at Climate, and that's one of the reasons why we were so interested in the company. And so we're trying to maintain that.
Right.
And it's you have to be aware of what you're trying to accomplish, and because there's just this, like I said, there's always this inertia of the larger company wanting to come in and we need to do it this way, we need to do it that way, and you just have to be vigilant and have, of course, the support of the executive leadership of the company.
So I'm going to open it out to questions, and I've got a question here, and also if anyone wants to stick their hand up, there's one over there, a gentleman over there, if you could take him a microphone. So the first question is, what formal methods does your company use to identify disruptive trends? This is a good question. Unpack their evolutionary precursive states and signal to the organization when actions should be taken. So, actually, in a nutshell, how do you innovate?
Yeah,
I like that.
It's a neat question. And I think it evolves over time. If you look at where we are right now, and if you take kind of from when we launched biotechnology, which was totally an in-house discovery at Monsanto, again, started in like 1980. As we moved through that, it was very quick. We quickly recognized that you need to go and find there's other companies in the space that are innovating, and that you have to go ahead and identify those companies. And we do that typically by asking our scientists to get involved in that. So you need to have a broad base of folks scanning the horizon. Most companies have a strategy group that are doing it as well, and that's fine to have it organized that way. But what we've really done in the past is ask the entire company to be out there trolling for ideas, and most of that's coming from the technical organization. And so we open the doors there. We've evolved now to a point where we have our own venture capital fund and a few folks in San Francisco called that. Their full-time job is to actually go ahead and look at emerging technologies, innovation in the space, and there's a lot of it going on in the digital ag space, and determining whether or not do we want to make early investments in the companies to accelerate growth. Are there companies out there that we would want to acquire? So it's kind of moved in my career. I've been at Monsanto for 25 years, so I've kind of seen this happen from kind of the skunk works, okay, who knows what's going on, and we're at scientific conferences, say this is really interesting, and building all the way to now where we have a formal, it's called Monsanto Growth Ventures, a formal VC group that is also out there looking at the space.
Sounds very similar to the same sort of problems they have in the pharmaceutical sector. I'll take the question from the gentleman over there. Did you get a microphone, sir? And could you please introduce yourself? Thank you.
Yes, my name is Tim Smith. As working in the life sciences, it seems as though there's been a move, as in Monsanto as well as your other medical products type partners, to outsourcing R&D to entrepreneurial firms and then bringing them in-house when they're developed. In contrast to models such as what I've seen at Corning, specifically Corning Glassworks, where they're still really focused on doing innovation in-house. Can you speak at all about what separates certain industries towards the model where it's more into external R&D and VC approach versus other industries where it still makes sense to bring it in?
Yeah, I think that's a interesting question, and the my view is that it's very, very dependent, as you said, on the industry that you're in. So, and the culture that you've developed within the company, and how much you're willing to fund internal discovery. At Monsanto, we spend about 10%. We spend about $1.5 billion a year on R&D, and I would say overwhelming 80% of that is spent internally. So some of it is clearly spent externally through collaborations and partnerships. And so I think if you look at different types of industries, I think there's a risk profile out there. So the pharmaceutical industry and the cost of developing new technology and the risk profile associated with that, I think the industry has clearly evolved to, hey, we're going to go out, we're going to try to find phase 2 or even phase 3 type molecules. Other people have made those investments. Some of the risk has been mitigated, and it's a better place for us as opposed to bearing all the risk through internal discovery. And so I think it depends on the risk profile of the industry in some ways. Again, I'll use agriculture as an example and kind of compare it to pharmaceuticals because we're doing a lot of similar technology. We're probably the world's most enabled DNA sequencing company in the world. We're doing molecular biology, but we do experiments on plants. Right? So, we generate 10,000 plants and we're looking for one, the human trial piece, it just doesn't exist in our industry. So there's a different risk profile. So I would give that as an example. I'm not as familiar with Corning, but I do think those are some of the key factors that would go into whether or not you're out. How much of this is looking for developments out or innovation outside of the industry or outside of your own company versus doing it internally.
So we've got a few short minutes, and we've got a choice of questions. So one question I had wanted to ask you, do you know what, I'm going to throw it to the audience. Let's just be fair. Nice summary of the first revolution in the 1940s, followed by biotechnology in the 1980s and 1990s, and now the green data revolution. Looking further into the future, what do you see as the next big thing? And can I also piggyback on that question? That issue we talked about briefly about whether the green data revolution can do as much as the green revolution before it to sort of feed people.
Yeah, sure. So let me kind of start there, and then I'll transition to the question on the screen. We started the session off about the demographics, and hey, there are going to be 9.5 billion people on the planet by 2050, and essentially arable land's decreasing. We're going to have to figure out how to produce more and less land more efficiently, and it's just difficult for the numbers not to suggest that's where we need to go. And so we're going to need technologies to do that. The digital or the green data revolution. What's I think the opportunity there is that a grower today will go plant their field, a uniform, high productive hybrid, right fertility. Do everything right in the United States, which is the most productive farm economy in the world, and they'll go out in the fall and they'll harvest that field and they'll see 50, 60 bushel swings, depending where they are in the field, in productivity. And so in the past, if you go back kind of, in the green revolution early on was all about breeding, that was all about genetics by environment. Those were the two variables that growers had to play with, genetics by environment and how you began to and you couldn't really control the environment, so your only knob you had to turn was genetics. So there's an enormous variability still on the farm that's not simply explained by genetics and environment by itself. It's a much more complicated problem, and so the digitization of the farm will allow us to be able to bring data science data models, and analytics to these problems. And the whole idea is that we believe we can go ahead and reduce the risk, so take the CV around that distribution and make it narrower, okay, and drive the mean yields higher. And that's going to come from our ability to deconvolute all the other variables that are going on in the field. So it's soil, it's weather, it's as I said, modeling weather and climatology. It's nutrients, it's germplasm, it is the traits that you use. It's a variety of, it's drainage in the field. There's about 40 different decisions and variables we've identified that a grower makes every year in their field that go into ultimately the yield. So, that's, I think there's tremendous opportunity here. There's tremendous opportunity, and that's why this is the next revolution. What do I see next? So first of all, I think we're early on. I think with where we are right now with the digitization of the farm, a lot of data out there, but not a lot of upgrading the data to help growers make decisions. So in the near term, 5 years, I think you're going to see, and what we're focused on at Climate is taking that data and deriving that into insights that are going to drive productivity on the farm. I think in the future, you're going to begin to see further automation in the farm, as I mentioned before. One of the things that growers are looking, I think farms are going to get larger. We're already seeing that in South America. So this automation piece is going to be very, is going to drive a lot of change in agriculture. Consolidation of farms, we're seeing that, and that will continue. So farms are going to get bigger, they're going to get more technified, they're going to be more data-driven versus bias-driven, and it's going to touch a variety of sectors all the way from, the John Deeres and not having people sitting in their tractor to telematics and, we haven't talked about UAVs and drones and whether that's going to have a place in agriculture, but satellite imagery, those types of remote sensing and sensors in general are going to play a huge role in the future.